Let's do one more. This is going to take a little while. It's going to go onto 2 screens for sure, but this is also my last example for today. Very last new material for this semester. Here we go. For example, we are going to have my matrix A equals this: 0, -1, 2, 0, 2, 2, 0, 0, 2. Reading across: 0, -1, 2, 0, 2, 2, 0, 0, 2. And again, same system of equations. Vector x prime equals a times vector x, and same directions, find a general solution. Okay, do I have homogeneous and constant coefficients? Can I use the same method I've been using all chapter? Give me a thumbs up. Homogeneous and constant coefficients. Yes, good, yes, okay. All right, so 0 equals the determinant of lambda I minus a. So that's going to be the determinant of lambda 1, -2, 0, lambda minus 2, -2, 0, 0, lambda minus 2. Can I trust that you can do that determinant? There's actually lots of zeros in this case. Can I trust that you can do that determinant and we can get to an equation factored out? It turns out that lambda is going to equal 0, 2, and 2. Okay, so that's going to be what we're going to have here. Lambda equals 0, 2, and 2. I think I am going to have you do lambda equals 0 yourself. So lambda equals 0, we know, is not defective. This one's totally fine. Lambda equals 0 only shows up once as a root. The algebraic multiplicity is 1. So we know for sure that lambda equals 0 is not defective. This one I want you to do yourself. Take a minute, plug in, see if you can get your eigenvalue. This is the stuff we did yesterday, okay? So go ahead and do that. I'll start writing and I won't talk. I'm going to call this V3 and X3, even though we're doing it first, because I'm going to get V1 and V2 from the next eigenvalue. And so we're just going to say this is the third one that we're getting out. We're going to get V3 and X3. All right, so we've got leading variables of V2 and V3. V1 is my free variable. I can choose V1 to be anything I want. I picked 1. And that it ends up that V2 and V3 both have to be equal to 0. So my vector V3 is 1, 0, 0, but you could have anything you want in this first entry right here. And then my vector X3 is 1, 0, 0 times e to the 0t. Give me a thumbs up and tell me we're okay with that part. That part's good. Any questions there? Okay, next part then. Let's do lambda equals 2. So next part, lambda equals 2. Here's my matrix. I don't know if this is defective yet. I am going to have 2, 1, -2, 0, 0, -2, 0, 0, 0. I think that's right, but double check for me, please. It's on the previous slide and I'm not positive. 2, 1, -2, 0, 0, -2, 0, 0, 0. Is that right? You're nodding at me? Good. Okay. All right. Once again, I actually don't have to do any elementary row operations in this case. That's great. Everything's nice. So we can identify leading variables. That's going to be V1 from this 2 up here and V3 from the -2. And therefore my free variables are V2. So you can find leading variables and free variables. Is this defective based on what I just did? Defective, give me a thumbs up or thumbs down, yes or no. Defective, yes or no? Yes. Defective, yes. This is defective. So Seth, this is the example that you were asking about. I have a non-defective eigenvalue and I have a defective eigenvalue. So we're kind of mixing and matching techniques here. All right, so this is defective. That means I need 3 things. First of all, lambda I minus a squared times V2 equals 0. Lambda I minus a times V2 equals V1. And I need V1 not equal to the 0 vector and V2 not equal to the 0 vector. Daniel, you had volunteered to square a matrix for me before. Do you have that matrix squared for me? Or you're getting there in just a minute. If I have lambda I minus a, you can read it off. Oh, wait, we've got it. Okay. Lambda I minus a squared is 4, 2, -6, and then a bunch of zeros. Thank you. All good. 4, 2, -6, and then a whole bunch of zeros. So that's going to be my lambda I minus a squared. 4, 2, -6, and then a whole bunch of zeros. Again, let's call these A, B, C, just to do it. So I've got leading variable of A and free variables of B and C, right? Leading variables of A, free variables of B and C. I can pick anything I want. It doesn't matter. So let's go with our typical choices that we had before. Choose B equals 1, C equals 0. Again, it doesn't matter. You can pick whatever you want. It doesn't make a difference. I'm going to choose B equals 1, C equals 0, right? And then my other equation is 4A plus 2B minus 6C equals 0. That's my other equation, right? 4A plus 2B minus 6C equals 0. All right. If you solve for A, doing some quick mental math, it ends up that A is equal to -1/2. A equals -1/2. Quick mental math, that's not one you can hold up easily with your fingers, so I'm not going to ask you for it. All right, what this tells me is that V2 is equal to the vector -1/2, 1, 0. Do we see that? -1/2, 1, 0. Pretty good? So far, so good? Okay, that was step number 1. Here's the other thing that I need. I need lambda I minus a times V2 to equal V1. That's how I'm going to find my V1 in this case. So V1 equals, I can't see my lambda I minus a because you're in front of it, 2, 1, -2, 0, 0, -2, 0, 0, 0, times -1/2, 1, 0. Okay, do your matrix multiplication. I'll do my matrix multiplication. Multiply that out, see what we get. Should get the vector 0, 0, 0. Get the vector 0, 0, 0. That is sad and problematic because I needed V1 over on the left side of the screen to not equal 0. Therefore, what that means is I made a poor choice. I chose poorly when I said up here, choose B equal 1, C equals 0. I am going to need to choose again. not a big deal. We just got to do a little bit more algebra. But that was a poor choice because I ended up with v1 equals 0, and then I won't get linearly independent eigenvectors. So we're going to say this choose here was a poor choice. That's sad. Can I erase my choose so that I can keep everything on this same slide? Are you okay with that? I'm going to erase and just write over the top of this. Is that okay? Are we all right? We can do that? Okay. Normally this would be like the worst teaching technique ever, but we're going to erase here and we're going to redo our choose so that hopefully I get a better choice out next time. So let's try a different choose. Let's try if I do choose, I don't know, b equals 0 and c equals 1, maybe. Let's try that. We'll try that. B equals 0, c equals 1. Then I still have the same equation here. So a is going to be equal to 3 halves, right? If I do these, a equals 3 halves for my chooses. And therefore, my vector v2 is 3 halves, 0, 1. Hopefully, I made a better choice. Let's see if we made a better choice. Once again, we need v1 to be lambda I minus a times v2. So in this case, that is going to be 2, 1, negative 2, 0, 0, negative 2, 0, 0, 0, times what I just had, 3 halves, 0, 1. Hopefully I don't get zeros. Hopefully I don't get zeros. I do not get zeros in this case. I will get, let's see, 1, negative 2, 0, I think. Do we like that? 1, negative 2, 0? Nodding at me? Okay. And once again, this is v1. So my vector x1 is from the previous slide. Vector x1 is v1 e to the lambda t. So this is going to be 1, negative 2, 0, e to the 2t, right? 1, negative 2, 0, e to the 2t. And my vector x2 is v1t plus v2 e to the lambda t, v1t plus v2. I'm going to combine the stuff inside parentheses into just one vector in this case. So this is going to be t plus 3 halves. Make sure you see where that's coming from. Maybe we'll write it as 1t plus 3 halves. 1t plus 3 halves. Do we see where that's coming from? 1t plus 3 halves. Negative 2t plus 0 and 0t plus 1. And all of that is times e to the 2t. Tell me you see where that's coming from. Give me a thumbs up. You see where that's coming from. If I write it out and combine it, we're good there? Okay. Final answer, final solution. And again, I won't write it with separate variables or vectors, but you could. I'm running out of space on the bottom, sorry. Final answer is vector x equals c1 vector x1 plus c2 vector x2 plus c3 vector x3. And as long as you have everything nicely and clearly labeled up to this point, you do not have to rewrite x1, x2, x3. You can if you want, but you don't have to. That's a lot. I think you're caught up writing, maybe. I think you're close to caught up writing. Let me see all of you again and see how we're doing. How are we doing? Zach, questions?
On that last one, does it matter what we label x1, x2, and x3?
No, just as long as you have your 3 linearly independent solutions to the system of equations. So you can label them in different orders if you want to.
Okay.
Did I answer your question or not?
Yeah, I was just confused how we started off with an x3 equals.
The reason that I started off with an x3 is because in your notation, when you have a defective eigenvalue, your notation here gives you a v1 and a v2, and those usually pair with an X1 and an X2. So I just wanted to keep the subscripts kind of sort of the same, but you can do them in any order you want. It doesn't make a difference. I'm just running out of subscripts, and therefore everything is kind of overlapping and going together. So that was why I started with X3, because I knew I was going to get V1 and V2 and X1 and X2 in the next part using our normal notation. That's why. Other questions? Other ones? How are you feeling about this? There's a lot of steps in the process, but hopefully they have been structured enough so that they're relatively the same all the way through. And then we've just got little pieces where stuff is breaking off. Like, do I have a defective eigenvalue? Or do I have complex eigenvalues? And we just kind of have to take different branches, but the basic structure, the initial part of the problem is all the same. Tell me we're doing mostly kind of sort of okay and you feel relatively confident about tackling the homework. Ish. Okay. That is the end of new differential equations material for the semester. You are allowed to be excited about that. I will be honest with you and say that this is not one of my favorite classes to teach. It's fine. I don't hate it. I hate analysis. I don't hate this, but it isn't one of my favorite classes to teach either. And the reason is because it's so much procedure. It's so much stuff, right? Like there's so many steps, and if it's this, then do this. And if it's this, then do that. It's not my favorite. I would much rather do linear algebra or abstract algebra where we've got big ideas over the course of the semester. Maybe the best way to say it is I feel like with this class, we can get stuck in the weeds really, really easily and lose track of the overarching problem. And I just don't like that. So it's fine. It's good. It's necessary. It's just not my favorite class. That's all it is. Daniel.
Do you know how much you normally get to if we didn't have the whole verse thing in chapter 3?
Yeah.
Like, is it usually like one more section or something? Or
yeah, we would do 3.1, 3.2, and 3.3 in chapter 3. That's how far we would get. However, that said, this is interesting. Professor Book said that when she taught at Bethany, the textbook they used there did not cover the stuff in chapter 3 at all. So I've only ever used this textbook, and I thought that we have to do power series methods in order to have like a valid differential equations class, but apparently that is not the case. So I may be looking for a different textbook the next time I teach this that does not, in fact, include power series methods. We'll see.
I mean, it's good for physics.
Like it's good for physics, right? And that's the balancing act that, yeah. But that's the place where it's super easy to get knee deep in the weeds. Also.
Yeah.
Okay, other questions, other things. This is also not a great class to finish out over Zoom. I'm sorry. This is the hardest one I think that I've been teaching up to this point. I just need more chalkboard and more being able to see you and gauge your reactions. And it's been fine. Like, I think we've made it. It's worked. It's okay. But this has been a really hard one for me to do over Zoom. So hopefully that hasn't come across to you also. I don't know. We'll see. Going once, going twice for other questions. Okay then, tomorrow I will post the review group work shortly before class. I would encourage you to log on. We can answer questions. You can work with your homework partners, all of that fun stuff. Same thing for Friday. Zach, yeah.
I was just going to ask what we're doing on Friday. But
Same thing, yeah. So I have the review group work divided up into 2 parts. I think, I got to go back and check. I think it's chapters 1, 2, and 3. And then chapters 4 and 5. I think that's where the split is, but I'm not positive. Also,
what time is the test next week?
Final exam is Wednesday at 10:30. Wednesday at 10:30. And we won't sign on early because I don't think it's going to take you the whole hour and 45 minutes. So maybe sign on a minute or 2 early. Like, don't be popping in at 10:30, but a minute or 2 early as opposed to super, super early. And then we'll get you going. Same directions, turn your camera on, take a picture and upload it as a PDF when you're done. private, I'll remind you of all this stuff next week, but private chat me when you're done so that I know, and I don't sign off of Zoom until I get confirmation that I've gotten your test, all that fun stuff, same stuff as the previous Zoom test. Anything else for other questions? Okay. Thank you for putting up with differential equations virtually the second half of the semester, and especially, and I'll say this again on Friday and probably again next Wednesday, thank you for letting me teach synchronously. You have no idea how much easier this is for me than pre-recording lectures. This is huge. So thank you so very much for letting me lecture synchronously. This is way better and way time-saving than anything else would have been. I so very much appreciate that. I'll send out homework, and I'll see you guys tomorrow for part 1 of the review group work and whatever questions you have. Have a good afternoon. Thanks.